In this section, we're going to be talking about the ionic bonds, which is our section for 5.4. And just let me start at the top that this overview screen might look a little bit different if you remember from 5.3, and that's because in sections 5.4 and 5.5, I thought that they were a little too long and a little too complicated, so I decided to take those two sections, break it up into three, so all these topics are a little bit more easier to digest. So in this section, we'll get started with the 5.4, the ionic bonds. And here's our vocabulary. These are the terms that we'll be using in this section, and you'll be more familiar with these by the end of the video. So we have the chemical compound, chemical bond, ionic bond, ion, electrostatic force. And the last two, I want to point out that I did highlight these because they might seem very similar and interchangeable, but pay attention because these two will be, it's important to know the difference between these two. So we have the cation and the anion. And I'll tell you more about that when we get to those slides. As a quick overview of the chemical bonds, you need to know that when two atoms are joined together, they form what we call a chemical bond. This is a force that is holding the atoms together. And the source of that force is the valence electrons. All right, so it's the valence electrons of these atoms that are holding them together. That's why we've done so much work with the Lewis dot structures and knowing how many valence electrons each atom has. This is the whole basis for our chemical bonds. And when two or more atoms are bonded together by a chemical bond, we call that a chemical compound. And they are bonded together in a specific ratio. So what do I mean by this ratio? Well, see here this example of carbon dioxide and carbon monoxide. Now, these are two very similar compounds because they're both made of carbon and oxygen. They have the same elements, but notice that they have a different number of oxygen, where CO here only has one oxygen and CO2 will have two oxygen. And so I know that's a very small difference between the two, but that's enough to make them different compounds, and they will actually have different properties. All right. So that's really just the basics of a chemical compound. We'll get into more details, especially in the next section with covalent compounds. But for now, we just need to know this, and that based on the elements that are involved in our compound, we get different types of chemical bonds. So, and in this section, we'll just be focusing on the ionic bonds. So let's see what ionic bonds are all about. So specifically, and the easiest way to pick them out is when you have a metal and a non-metal element bonded together, they form an ionic bond. And so just as a quick little reminder on here, when we have the periodic table, it's mostly metals. They're all on the left side, but then we can also have the non-metals on the right side. So when you get a chemical compound that's made of both metals and non-metals, we get an ionic bond. And we'll see some of the other features of that in just a second here. So now the ionic bonds are characterized by this transfer of electrons between atoms. So let's look at what's going on here. Here I have two different atoms. On the left, I'll have a metal atom, and on the right, I have a non-metal atom. And what's going on here is that I've drawn their valence shells, their electron configurations. And so we have here on the metal atom, we have one single lone electron in the outer shell. And so it is moving towards the non-metal atom to complete the outer shell of the non-metal atom. And the reason that this is happening is because of electronegativity. If you remember back to our unit on the periodic table, we have different values of electronegativity, and they're highest by fluorine, they're highest on the right side, and they're very low on the left side. So you can see that if you remember what electronegativity is the ability of an atom to hold on to electrons. So you see the metals on the left side have very low electronegativity, which means it's very easy for them to lose an electron. And on the opposite hand, for the non-metals that are on the right side, they have very high electronegativities, so they grab onto a lot more electrons. That is their fair share. It's a general rule. Something that will help you remember this is that the metals will tend to lose electrons. They give them away, and the non-metals usually gain electrons. And it's so important that I'm going to put a box around that and make sure that you highlight this in your notes, because this will make your life a lot easier if you can remember this. So let's talk about charged particles. So now everything that we've talked about for atoms on the periodic table, all the elements, we're talking about them in their ground state. And we see that they're neutral particles. That means that they have no charge. And the reason for this, let's look at this example of sodium. So if we take this diagram of sodium, we know that its atomic number is 11. That means that we'll have 11 protons and 11 electrons. Remember that protons are positive, so we have a plus 11 charge from the protons, and the electrons are negative, so we have a minus 11 charge of the electrons. And when you balance them out, you get a total charge of 0. That's what it means when our atoms are neutral. But when we mess with the number of electrons, so in this case, if we take one electron away from the sodium and we get 11 protons and 10 electrons, in that case, they're not balanced out. We have one more proton than we do electrons, and overall, we'll have a charge of positive 1. And so when this happens to our atoms, we give them a special name. They're not atoms anymore, and they're not elements. We call them ions. Now, when we make ions, the only thing we can change about an atom is the number of electrons that they have. We can't change the protons because that changes the element that we're dealing with, but we can always change the electrons to change the charge on the atom. Now, think of it this way, because we can have two types of ions. And if we are taking away electrons, we are losing negative charge and we become positive. We call that positive ion a cation. Now, it's not cation, it's cation, so pay attention to the pronunciation on this one. And then if we do it the other way, if we are adding electrons, or I shouldn't say adding, if we are gaining electrons to our ion, that means that we're getting more negative and we get a negative charge. We call that the anion. And again, remember that rule from the slide before, that metals tend to lose electrons, and when you lose the negative electrons, you get a positive charge and make a cation. And for the nonmetals, they gain electrons, they get more negative charge, and they become negatively charged, and they become anions. And a good way to remember this is that cations, remember that pronunciation, cations, they have a positive charge. Excuse the bad pun, but it's a good way to remember it. Now that we've talked about how to make ions and what the difference between the ions can be, let's talk about how they are bonded to each other. And really, for these type of chemical bonds, the ionic bonds is really more just an attraction. So attraction is caused by the electrostatic force. And so when we make ions, they get a charge. It can be either positive or negative. And remember that the opposite charges will always attract. You might have heard this before, that opposites attract. And so it's the same thing is happening with our ionic bonds, that we have some particles that have a negative charge and some particles that have a positive charge. And when they come close together, they are attracted to each other, kind of like the two sides of a magnet. The North Pole and the South Pole are always attracted to each other. If you try to hold two like sides of a magnet together, they repel each other, and our ions do the same thing. If you have two positive ones, they will repel each other. If you have two negative ones, they'll repel each other. But if you have one positive and one negative, if they're opposite, they will stick together, and it'll take some force to separate them apart. And so that is the force that is holding our ionic bonds together. It's the electrostatic force. It's that difference between charges between different atoms. And in our activities, we'll be working to balancing chemical charges and just making sure that our ions are completely balanced.